Greetings everyone. Welcome to the second onboarding seminar. I've got Jake with me here today. He's going to be doing a bunch of practical demonstrations. We've collected all your questions behind the scenes and we've tried to get some little demos and examples ready to go. So most of them, or a good chunk of them, will be covered in Jake's demos. And then at the end, we'll get back to all the ones we've missed, hopefully. We'll be keeping an eye during the chat, during this seminar, looking at the chat, and we'll try and answer those as well as we go. So yeah, today's going to be more practical. It's going to be more application-based. We're going to go through actually cutting rather than just linking to all the docs and things. So we'll hopefully see some examples of how all this works. So yeah, we'll go to the slides now and look at what we've got lined up for you. So we're going to start with offsets. So this is an area that can be kind of confusing, but once you understand what goes on, you'll see how powerful they are. It's one of the huge advantages of Origin, especially when you don't have to reach for a Forstner bit that's larger by a whole 1/8 of an inch or something. You can just take another 1,000th of an inch off with Origin, and we'll play out that. The rest there is kind of clear. We'll go through cutting, text, inlays, mention assist, and some software info. So I think anyone who's reached out with the form and asked some questions, you'll recognize that in that, and we'll get through the rest as well. So before we get into this one looks a little technical. We'll go back to Jake, and he's going to walk you through offsets.
Down here, I have a series of holes, 1-inch holes, to fit a 1-inch dowel. Now, if you've ever used dowels, you know that the sizing of dowels usually varies rather widely. This one's actually pretty solid, close to 1 inch. So what I've done is, in this series of holes, I have my different offsets. Now, offsets, as we'll go deeper into later, is how far into or away from your final cut line that you actually are. So if you show my Origin screen, I'll just give you an idea. Here, I have my roughing pass, which is I use a 0.02 inch offset. Over here, I have my 0, a negative offset, so now I'm cutting into my design slightly, and then an exaggerated one, and we'll just show the different fits. So just to put that into real life context, I will show you my roughing pass. There's no way I'm going to get that to fit. 0, if I took a hammer to it, I might be able to, but that's not the kind of fit we're looking for. Negative 0.01, really too large of a negative offset. It's going to give me that. That's not the kind of fit I'm looking for. I'm looking for a nice, tight friction fit, which I bet 5,000th is going to be perfect. Not moving on us. Nice and solid. Plenty of room for glue. So I want to take this 0-inch offset hole. I want to bring it to the right offset, which is a negative 0.005. And since I have my workspace saved already, I can do that. I have my 1/4 inch cutter in. I'm going to go ahead and best practice, just Z-touch before I get started again. And right here on the left side of the screen, edit my offsets, go with a negative 0.005. And the negative, again, is really important when you're dialing in fitment rather. I want to creep up on that little by little until I achieve the best fit. I just know in this case that 5,000th is going to be perfect. So I'm going to make a quick cut here. And there we go. That's that exact fit that we were hoping for. Just taking off 1,000ths of an inch, even coming back to a workspace and being able to edit it because I haven't taken my tape away. That's the most important part.
So it's usually a case of measuring, doing a test with one element, and then rinsing and repeating across the whole thing. If you were doing all these holes on the top of this table, you could measure once and then come back and nail it every time.
It's always good to have a handy pair of, I like digital calipers. I have them on me or close to me at all times when using Origin, because you can measure your depth with it. You can always double check what you're working on.
So we'll go back to the slide deck and we'll have a quick look at the this here. So this would have looked a little confusing initially. What we're looking at here is the green lines show the shape we're cutting. So if I tell it I want to do a 0 offset, that is the first one in the top left. We're going to cut that at the exact dimension defined in that SVG file, and it holds up. The same applies with on-tool design. So if you create a circle that's 2 inches across, a 0 offset will cut you a shape that's exactly 2 inches across. Moving on to the next one, so a positive offset, oh, sorry, not next slide, next image. A positive offset leaves material. So you'll see there, if I do, say, a 0.1 inch offset that's positive, I leave extra 0.1 of an inch on all dimensions. So you can see that layer of green shows me the extra material left. And then the same holds true if I do a negative offset. I'm removing whatever dimension I describe as my offset. So it makes it smaller, or sorry, it removes that dimension. So if it's an inside cut, it will make it larger. If it's an outside cut, it will make it smaller. I hope that makes sense. It's actually, maybe we can look at just the screen for a second and create a little, a single circle, and then just do an exaggerated offset with it to show it how that works.
Okay.
So just do a 2 inch circle. And then, you know, you can type this in. I remember that popped up last week. You can either type in or click and drag for circles.
Yes.
So this is an inside cut. We'll move to cut mode. At the moment, there's a tiny offset, so we can barely see it. So we're going to exaggerate that, so to 0.1, say. So that's a 0.1 positive offset. So it's leaving that 0.1 inches, and you'll see the toolpath is updating live to leave extra material. The final 2 inch dimension is the green line, and you've left an extra 0.1 inch the whole way around. If we swap this to an outside cut, and then move to the outside, you'll notice it behaves the same way. We're going to create a 2 inch puck that we bring out instead of a hole, but it leaves that extra 0.1 inch the whole way around. And then you can also do a negative offset, and you'll see it'll overlap that line. So it'll take a 0.1 inch. So it's going to make it slightly smaller in this case. You can see the toolpath is trimming more off beyond your green line. And then the same applies if you flip it to an inside cut. That'll become second nature to you. Just know that if you're making a hole, a negative is going to make it larger, give you more space for glue, and positive makes it smaller, making the more friction when you go to fit it. So we will now move on to the next section in the slides, sorry. So we're going to go through, Jake is going to demonstrate some of the basic concepts of cutting. So one of the questions that cropped up was, can I set up tape on a panel and then reuse that tape, like put elements next to it and not have to constantly be taping up my plywood panels? And absolutely you can. And Jake's going to walk you through, some of the ideas there, how to make the most out of that.
Couple of key things here to remember. One, when you're cutting, whatever you are, the piece that you're cutting and your tape board need to be the same thickness. I have a piece of 3/4 ply here. I have it all taped up, and my positive piece is also a piece of 3/4 ply. I find myself when I'm using hardwood, I will join and plane my material down to similar thicknesses to my plywood, just to make a tape board easier, unless they're small enough to where they can go on the workstation. But in this case, we have a larger leg going on. A little bit of double-sided tape on the back. First, I want to make sure my tape board is secure. And I will make sure my material is secure. Because the most important thing when doing this, and the somewhat dangerous thing about doing this, is these two things aren't connected directly, so they can move on you, and which will throw off your whole project. If your tape field moves relative to your design, you will see problems. So we want to make sure that everything's nice and secure. And again, this is what I'm cutting. This is what I'm looking at. Oftentimes, if this is a board that's going to be used over and over again, you might see some abrasion over a long period of time. Getting something like this, which is
it's like a protective plastic film. I think
Yeah.
it's like ultra high molecular weight plastic. But
Exactly.
some people use packing tape.
Yep.
It's up to you.
Very similar to what we put on the workstation. Just something to give that tape a little longer lifetime. So I put it over just mainly this front section because in this case, maybe I plan on cutting 100 of these table legs and I'm registering off the edge, or I have a registration pin and I'm just going to keep swapping this part out, cutting the leg out, moving on to the next one. So I'm going to bring my tool over and I'll do a quick scan.
So this is the same scanning process we saw last week, where basically you see Jake moving left and right. He's trying to overlap each strip of his scan so the camera can join it to the previous scanned element. So you see the markers turning blue where they've been recognized, and you'll notice he can lift it up. He doesn't have to remain dead flat on the surface, but he's moving smoothly and just making sure he's always overlapping existing tape field.
Just piecing all those images together. And now what I always like to do, jump out, just make sure you have a nice solid tape field. I'm down here where I'm actually going to be cutting, and I have solid black tape marker all the way across. The tool is happy, we're happy, we're ready to go. I am going to bring in that leg file that we were talking about because I think it's a good example of cutting mechanics and body mechanics, really. So right now I'm just visually placing, and I'll pop that right there.
And you'll notice, like, Jake was able to see the seam between where his stock was and the tape board was. He's also put a little buffer along the top there because he knows he's going to cut on the outside of the line. So if you're running a 1/4 inch cutter along there with a little offset, always leave a little 1/4 inch space at least at the top.
Yep. So for the sake of this, we're just going to air cut. I'm going to set my offset to 0. Ooh, actually, I'm going to scooch this over because I'm running into my workstation. Move that and go grab it again.
So if you couldn't see there on this side, just because we're demonstrating, the workstation is very close to this piece of stock. Usually you have a clear space around you, so you can always move and your handles can get everywhere they need to whilst cutting. It's sometimes a good idea to do a little air cut before you start cutting, just to confirm that you can actually get everywhere on the part you intend to cut, and you can see enough tape as you go.
Okay, so the reason I like this as a demonstration is we have long sweeping cuts as well as intricate joinery parts that need to be nice and tight and 90-degree corners. So I'm going to start here up the top of the leg. Oftentimes when people are first approaching Origin, they want to treat it similar to a plunge router. They want to muscle it, they want to grab it really stiffly. And if you could show this camera, their arms are very stiff and they're driving the tool more so like this. You should still have a firm grip on the tool, but it's more about connecting the tool and your body and using the fluidity of it, the whole thing, to get a smoother cut. So as I'm coming across, my body is coming with it versus staying in one spot and driving the tool necessarily. So back to the screen, and I'll just show you locking my elbows kind of into my side, coming around. Anytime I approach a corner, I slow down and I just bring it across, not aiming to keep that dot in the center of my crosshairs, but really just making sure my movements are fluid more than anything else. These are the times where you can pick up a little speed as soon as you get comfortable, but always be sure that when you start coming towards the end, you slow down, pause, especially if you can get the entire corner in your corrective range. That's when we're going to use our auto. let the tool do the fine motor work for us. Just help it get around those parts. Again, kind of long straightaways. Slowing down. Not stopping though. Not stopping like I am and letting the bit burn there in that same spot. I want to be pretty quick on my feet as I come around things like this, but very intentional in my movements. And finishing. And retract. Now this is for larger cuts. Later I can actually show what finer motor cuts look like. I'm going to come over to my workstation. You see here we just have the positives of my inlay cut. But when we're doing smaller things, what I do, you can go over to this camera, I really use the side of my hands to stabilize the tool. So when I'm coming down, that side of my hand is resting on my work surface, whatever it may be, and I'm using a lot more fine motor control just to kind of ease the tool around sharp corners and help. Sometimes I even, if I'm doing long straight lines, I'm hooking my finger around an edge just to make sure that that everything's nice and stable.
With that in mind, I guess it's worth mentioning, like, Origin is incredibly good at handling sort of drift. Like, take advantage of that correction range and let Origin take care of the precision for you. So rather than, some people get too aggressive about trying to keep the dead center, the cutter in the dead center of the correction range. So they'll do things like add a jerky motion to try and compensate, when they should just let the cutter drift through the correction range. So long as you keep it moving smoothly, you'll get good outcomes.
Yep.
Should we move on to the slides again?
Yeah.
Yeah. So that was a brief intro into, you know, the sort of approach to cutting with Origin, getting the best outcomes. We'll get more into the actual process of cutting now, but more, that's the motion and action and strategy of how you'd approach that. So if we were to cut, say, 3/4 of an inch deep, one of the techniques we use is common in regular CNCs and things, where we do a roughing pass and we'll cut, say, 3 passes to get to the final depth. So roughing passes are just to clear out material. It's to be efficient and just get the process moving, get all the material out that we can fast, and then we save our really accurate cuts for what we call a finishing pass. So you'll see here one of the reasons why we do this. I've pointed out the little witness marks. So that's kind of fuzz that's left. If you were to cut with the same offset and then go, you know, an offset of 0 at 1/4 of an inch, 1/2 an inch, and then 3/4 of an inch, this is the outcome you'd get. And you'd have to sand it a little bit. So what we do is we do roughing passes, which is we leave this is bringing back the concept of offsets. So you leave a positive offset and say 0.01 or 0.02, a very small positive offset, and then you come back at the end with a 0 offset when you're at the final depth. So for your last pass, you're cutting at the final dimension, and what the key there is the cutter is effectively very unloaded. It's just doing a final finishing cut where it cuts through the full depth and it clears away all that fuzz and everything, and you get a very accurate outcome because the cutter's not deflecting, it's not loaded. It is tempting to move quickly for your finishing pass, but once again, Jake's actions, make sure you're moving smoothly, the same as you would ordinarily, and you'll get very accurate outcomes. So we'll go to the next slide. So yeah, the concept is, you know, you want to cut I forget what it is, 3-inch circle, place your outside cut element. Next slide. That goes on your stock. We've got a little section line through here, so we can sort of see what this looks like as we go. So next slide. So the first pass, you can see the settings down on the bottom left there. So the rule of thumb for smaller cutters, like our stock 1/4 inch cutter, is to not cut deeper than its diameter in one pass. So you notice here there's 2 things to keep an eye on. The cutter is the red thing, that's 1/4 of an inch. I've exaggerated the offset. So this is a roughing pass. So you'll see the the final dimension is the black shape. The offset is 0.02, and the depth is 1/4 of an inch. So we do one pass, 1/4 of an inch deep with an offset. This is a roughing pass. So we're going to come back later and remove that 0.02 inch offset. So then we just go through and we go second pass. This we can repeat, as long as we've got cutting flutes long enough, we can repeat this roughing process till we get to the depth we like. So this is the 1/2 inch one, this is halfway through. In this one, you'll notice I'm saying this is a 3/4 inch element, and I've set the depth to 0.73 instead of 0.75. So what we're doing here is we're intentionally leaving a little skin on the bottom. You see I've pointed that out with the arrow. That's a kind of a great way of holding elements in place while you cut them. If I was to go and cut the whole way through, I'd be relying only on that double-sided tape behind that shape I'm cutting out. So one thing worth noting is leaving a skin means that during this pass where I'm removing a lot of material, it's not receiving as much force across it on the side of it. So it's less likely to get pulled out of alignment. It's less likely to break out of the double-sided tape. So then when we come and do the final pass, next slide, you'll see here the remainder of that little skin. You can see on the edges there, but we've gone full depth. I've actually gone 0.78. I'm cutting a little deeper. But the cool thing is that one is less, there's less force on the side of your object because it's cutting so little material. So you're more likely, A, to get a better, cleaner outcome. B, you're not providing as much force on that double-sided tape, so it's less likely to break free. So that's the strategy of a roughing and a finishing pass. This last slide, it shows the finishing pass. You'll see the offset set to 0, and we've moved in by that 0.02, and you'll see we're cutting at the final dimension. And yeah, I hope that's clear.
I heard you mentioning the double-sided tape. I gotta ask, where do you get that?
The double-sided tape can be found on our store. Ted will post a link to that. So yeah, for a lot of these things, we're trying to find. We get a lot of questions. You know, what cutters are you using? What's this double-sided tape? All that sort of thing. If we find really good examples, we tried to get it up on the store to save you trawling around on Amazon all day. But yeah, do you want to get into your demo of that, Jake?
Yeah. We'll do some live engraving text, show a little on-tool text. So over here on our Create tab, down at the bottom, you'll see Text Basic. Now, for the sake of this, we will do our name. And the standard height is 0.3 inches. The reason we chose that as a default height is it fits within the corrective range. So you don't even need to move Origin as you're cutting this. The letter itself fits directly in. I've gone ahead and thrown in the 60-degree engraving bit that comes with the tool. Go ahead and, as always, we Z-touch. Just make sure. Making sure that our tool is solidly on our material. The front end of the tool where the touch-off bar is directly in the front is also on the solid material. And like I said, this is only an air cut, but I'm just holding that auto button and it's going through the entire shape on its own. So I'm going to edit this now to an engraving depth, which is a 0.02, and get through this. This. If you're wanting to speed up the auto process, down here at the bottom left of the cut screen, you can edit those speeds. Use caution when doing this because you don't want to go too fast that you're not going to get good quality cuts, but you want to give yourself a little bit more speed, say 15 feels better for this sake, and I can do that. Finish the letter is I'm going to actually double tap this green button, and then I do not need to hold it. It's going to auto lock for me. And there we have it. It's difficult to see because it's so small, but that is our default size engraving. It's just as easy to edit that to be whatever size you want. Keeping in mind, as you change your cutter or change your depth, the width of your cut or your engrave will change with it. So
just grab this.
Yeah, perfect example.
Show that. I don't know if that fits there.
So for this cut, kind of your standard national park sign, we used a bullnose bit, a 3/4 inch bullnose bit, still with a 1/4 inch shank, which when we dial in that depth, I only went 1/8 of an inch deep. It gives us that really nice kind of curved side edge. And this is still using the same on-tool text function. I just changed the size of the text to say 2 inches, 2.5 inches. We came down here and used a similar bit, but smaller. Also a bullnose, but at a 1/4 inch to do this. Over here, I have this set to the same depth, 1 inch, or 1/8 of an inch. And here I took half of that off and I went 1/16 deep, just to kind of show a little variation in how that affects it.
And then maybe you can talk us through how you went about coloring it and everything. What was the technique for that? And then we'll go back to the slides.
That is the fun process we call paint sand. So whether it be hardwood, plywood, softwood, whatever it is, a quick, easy way to make a fun sign is to cut into it, just as I have done, spray the entire surface with a spray paint, and then sand it back, leaving only the part that you've cut actually colored. Couple of tricks there. Wood is a bunch of fibers. It tends to suck paint through, so I advise doing some sort of a sealant before the fact, before you apply the paint, and that will help it from sucking paint into the grain as well.
And then we'll go back to the slides for the intro to text stuff. So yeah, we've seen Jake do tiny, sorry about the noise, hopefully it's not too loud. We've seen Jake do the tiny engraving and then a larger engraving. So there's several different approaches we can use to create signs and work with text. There's obviously engraving, then we can get into the paint resin pour approach. These are in order of sort of complexity or simplicity or how much energy you have to put into prepping for them. And then the final one is inlay work. So we'll go to the next slide. So this is, if it wasn't possible to see his initial engraving, it will look exactly like that engraving at the top there. So that's basic text, just engraving anywhere you like. So Origin's readily able to do that for you really quickly. And then getting creative with different colors and things and scaling it up, you can achieve with paint, the bottom option there. And then we'll move to the next slide. So we'll just talk through how, if you're not going to use basic text, which is the on tool, there's one font available there, which is the one we've just displayed. How would you prep that file in a software package? So basically, Origin takes text as curves. So what does that mean? If the text in your vector editing software shows as editable, like you can type it in and edit it, press the backspace key to delete it the way you would in an email, chances are that's live text. So most of the software packages we've ever used have the option of automatically converting that to curves, which is each one of them will be treated as like a shape, an SVG shape. You don't have the ability to type in more text. it treats them as any other shape. So it might be a star, it might be whatever. These happen to be text characters at that point. So you can either turn them into that in the app, or if you have a look down at the bottom of the screen there, there's support at shapertools.com and designing for Origin. There's various export settings for all the different vector editing apps that will include how to convert that when you save it as an SVG. Yeah, so we'll move to the next slide. So in the process of preparing a shape for inlaying, we'll get heavily into inlaying in a little bit, but basically with a round cutter, we cannot cut into these sharp corners. Like if we were to just cut this and pour paint in, it'd be fine because paint can flow into any shape that you provide for it with a pocket. Then we'll go to the next slide. So this is what Jake's going to show you in a second. What he's done basically is take the text, turn it into curves, and then round over those corners, both the inside and the outside corners, using the cutter diameter, the cutter radius for all of those curves, all of those sharp corners. So there's no sharp corners in this, which means he can cut the positive H and the pocket H, and they're going to be exactly the same size. We'll actually go through the slides and come back to this, yeah?
Perfect.
Yeah, so keep going. So here's where you might start, right? You want to inlay a sharp shape. It's a star. That's cool. But next slide. Yeah, then your goal is to cut the pocket, and that will all fit together perfectly, right? So we can tune that with offsets and get exactly the friction we want. So then next slide. And it will look like that. Everyone's happy. Well, it's not quite that simple, just because of the way cutters work. This is the same with any CNC. Basically anything with a kerf, you need to consider these sorts of things. So next. So when we're cutting the positive element, on all the inside corners, we get this little round over detail you see pointed out there with the arrow. You'll notice it is able to cut the outside corners very sharp, but then when we look at the next frame, the opposite happens when we're doing the pocket. So you can see the cutter in there. It's unable to get into those corners because it's a large round thing, not an infinitely small point that's cutting. So this is showing a 1/8-inch cutter going into the corners of a 2-inch star. So what we have to do, next slide, is consider all of these red elements I've highlighted here. So there's a couple of strategies for this. We can either chisel them out on both the positive and the pocket elements, or we can round the corners. So I'll just quickly show you what that looks like here. Next slide. So yeah, you just chisel those rounded edges on the positive, and then next one for the pocket. Go into those corners. So that, it'll save you a lot of effort, and you'll get very sharp details. We'll go to the next one. Or we can bake in the cutter radius into our file, and that way when we complete cutting with Origin, they'll just fit together. So in this case, we're saying we've got an 1/8-inch cutter, which means we'll make a 1/16 of an inch radius on all those sharp corners, both the inside and the outside. And this is talking about preparing the file in a software package, not on tool. So you do this in advance and then send it via Shaper Hub to Origin. So then next slide. And this is showing you if you used a smaller cutter, you'd get more detail. The points become more sharp. We'll link out to other videos that actually walk you through some of the process of doing this in various software packages. We're constantly making training material for that sort of thing. We won't get into just software details here, more just the conceptual grounding so you know what's going on when we go to do these things. So yeah, the smaller you make that radius, the smaller the cutter you have to use, but the more detail you get. So it's a balancing act between how efficiently do you want to cut this and how much detail do you want. Obviously, a larger cutter is going to remove more material more quickly, and a smaller cutter is going to get you more detail, and it's up to you what the most appropriate approach there is. So next slide. And yeah, this is showing like a really, kind of exaggerated 1/4-inch cutter, gets you a sort of blobbier shaped star, but depending on how close you are to it, that may be appropriate. Keep in mind, this does also bake in the scale of the object. One of the beauties of Origin, I think one of the questions actually mentioned, can I scale my logo on tool? And yes, the answer is sure. In fact, Jake might be able to go through that in a second. But the moment you start putting these radiuses into your file, you won't be able to scale the file down and still have your inlays fit unless you get a cutter that's half the size. So say you had a file designed for the 1/4" cutter, and you scaled your file down by half, you'd then have to use an 1/8" cutter to cut the same corner details. Hope that makes sense. It gets pretty clear once you get into it, and Jake will walk you through that now.
All right. Over on my workstation here, this is a fantastic way to cut smaller pieces on the shelf. I have a piece of roughly 1/8" material as my positive piece for my inlay, and my negative piece is over here. But I want to show this, and it's got my inlay positives. Got cameras issues? Can you go to my Origin screen?
We might have to power. Oh, yep.
There we go. All right. So these are my positives that I cut that I showed you earlier. I've cut these to a 0" offset because I know that I can edit my negative offset on my over there if I tilt this. I can edit the negatives over here, and I can dial in that fit by taking little by little off. So I start with 0. I always cut the positives first, and then I move to the negative. So I've cut these out. I've actually had them over here in Sapele. There we go. Apologize for that. So now I have my positive letters cut out of Sapele. That is not what we're spelling. We're spelling that. And I went ahead and started on this just for the sake of time. Whoops. And I'm going to change my workspace to, I like to name my workspaces. I have my positives, and I have the home inlay right here. So my offsets currently are all set to 0, and I know that that is a little too small. It's close, but I want to take a little bit more off so that they fit better. And I'm going to creep up on that. So I'm going to do a negative 0.02 and just take that off real quick. And I still have one more that I need to pocket. I'm going to edit that speed back down. Turn that to 0, and I'm going to pocket out this material here.
we'll just quickly, looking at the screen there, we'll just quickly walk through what's going on there. So that was, we were looking at pocketing. I don't think we displayed this last week, but what's cool here, and this is actually a common thing that happens on files like this, you notice at the top of the E, it doesn't join up the whole way. So just move up a little there. So that's, the pocketing operation has a little offset on it. So here he's using a 1/8" cutter, and that gap, the pocketing doesn't enable an 1/8" cutter to fit through that gap. So pocketing has to be done in 2 steps. At the moment, he's done all the pocketing, but it's not the final dimension because of that little offset. So he's going to now change it to an inside cut and then cut the final dimension. So pocketing is a 2-step operation. And if you ever find you have a shape that is a pocketing operation and it's not showing you your toolpaths or something, there's 2 things you can do. You can either change it to an inside cut just to confirm the dotted lines show up. You can also check your offset. So we'll actually go back to pocketing and just have a look at how it would display if it had an excessively large offset. So if this was 0.1, notice how there's no area available for pocketing. So it could be easy to go, oh no, something's wrong. I don't know why I can't cut that. So you notice as he uses smaller and smaller offsets, more and more of that pocket is available for cutting. And then when it's 0, it's most of it. But yeah, just if you ever find yourself not seeing a toolpath that you want to cut, just double check that offset. And then if you've got an offset of 0, the next thing to do, actually you can do the same, make the cutter diameter larger. So a larger diameter cutter will not be able to get into those areas in a similar fashion. So yeah, if you want to check if you can get a cutter in there, make your cutter a small size, make sure there's no offset, and then go from a pocket to an inside cut just to confirm you can actually get a cutter in there. They're the 3 sort of tips for navigating that. Actually, just before we get too carried away, and sorry, Jake, I'm totally
No, it's all right.
We'll give away a hat and a sticker pack to whoever can answer, thinking back to the previous demo, why do we perform a roughing cut with Origin? So you can answer there's several reasons. Ted's going to randomly select someone and then contact them in the chat. So yeah, that'll be a hat and a sticker pack sent out to you. And we'll get back to Jake's demo.
All right, I'm going to cut the inside of this. I'm going to do it in 2 passes. I'm going to do a 0.01 just because, this is a tight inlay. I want to make sure it's right. And then I'm going to do that negative 0.02, which we found that was a good fit. 0.01, I'll zip through this. Using auto when appropriate. Now I'm going to change that to my negative 2000. There we go. Maybe use my little sanding stick to touch up some of these edges. Again, because those up cutters tend to lift a little bit of fuzz, a little bit of the grain, but it just fluffs right off with a light sandpaper. Not influencing the edges at all, because I know that's going to fit well. All right. that up. I always make sure I mark the backside. In this case, it doesn't really matter, but I mark the bottom of my shape. That's what I want to see.
A couple of little notes here. If you're doing a dry fit, consider drilling a hole all the way through to the back.
Somewhere
preferably bigger than your, than that.
Exactly. If you can use that as your poking tool, it's perfect, and come from the back side of it to knock it out.
It's tempting to do a dry fit and then almost impossible to get them out again unless you plan ahead. And another thing that's interesting, like with all this, there's actually plenty of options for how you approach this. Like Jake could come in, and if he doesn't like the friction, he could take another 1,000th of an inch off. There's also, like I've had situations where I change my mind and will actually, because our tape is still aligned perfectly, he could mill out that entire M and place it again if he wanted. There's some pretty significant recovery options on the table.
Yeah, and especially
you make a mistake.
Especially because we've already cut another set of letters over here, which I'll probably end up saving for another demo. But yes, you could completely cut this out as long as we keep that tape and we don't move it. In fact, until my project's ready for final sand and finish, I'm going to keep that tape on there, just in case. So last letter.
That's a good rule in general. It's very tempting to take the shaper tape off and take something out of its fixtures and stuff. But keeping that tape in place means you can come back. Like we've had people realize they've made spelling mistakes, and they'll come back and they'll pocket out a little rectangle with a radiused edge, and then pocket, create a little positive plug, and completely, replace an entire letter in a sign or something.
Something I want to note too before we move on is when you're dealing with delicate materials like this, thin veneers or plastics or anything, make sure, and you're using a double-sided tape, getting a thin, flexible putty knife like this is going to really help you wiggle your way under these things and gently pry up that double-sided tape without breaking your pieces. So again, you got to think about that grain direction and what it's going to do. If I try to pry it up one way versus another, I like to wiggle the blade all the way through, get right under it, and then I can safely pull it up. And again, I just want to reiterate, always cutting the positives first before you move to the negative. Because we have this piece now, we know it's cut to a 0-inch offset, and we can do all our editing to the offsets and our negative offsets over on the negative portion, and slowly test fitting along the way.
So yeah, once you pop these out, you can no longer, it's not possible to then adapt them easily.
Yes.
Whereas, yeah, in the pocket, which has the tape firmly attached to it, there's plenty of options there. As long as you don't take a massive negative offset, we haven't invented a way to replace wood.
Not yet.
Okay, and then we're going to get into all the questions that you've asked. So feel free to continue adding them to the chat there. We'll get through what we can. But yeah, no, we'll let's see, are there any more details with that? There's a couple of things, like if you're doing really small inlays, a lot of people are tempted to have like serif fonts, very small pieces of detail that are actually very hard to cut out as positives. So if you find yourself creating a shape that's getting smaller and smaller, you'll find things like the wood will just chip. So you can do things like use a very small cutter, thin veneer, and you can maybe use a down cutter because the stock up cutters, they're pulling up off the tape, and you can actually suck them up the vacuum cleaner, which can be frustrating. So yeah, consider using a down cutter. And then at some point, things are going to get so tiny that it's not going to be appropriate to make a physical inlay. So that's where you can roll back to ideas like the paint approach or a resin pour or something like that. You can get a lot more detail when there's a lot of wood around something and you're cutting a little pocket or a slot and then just pouring resin or paint into that slot. I think some of these are interesting examples of Jake's made all these, and this is a resin pour. So these are getting pretty small. You can barely even see them on the screen. Pretty small. That would be pretty frustrating to make with fine detail with this type of in wood grain. People do a lot of fine detail for things like mother of pearl, brass, like soft brass. There's different types of brass, I should mention. There's like machinable, I think it's like 360 brass that's a lot better to cut. We've got some little examples here. You can get pretty small with that. I think I got a 1/64 of an inch cutter to do that, but it was really nice to work with. So just keep in mind, like, can you physically hold these small elements together? Like, even if Origin can cut them, that doesn't mean it's a great thing to inlay. So just with experience, you'll get a feel for what works nicely, and when it's a good idea to roll back to a different technique, be it painted or resin pour for the fine detail.
And coming back to the speeds adjustment that we were talking about earlier, when doing those final details, might be worth going back into your speed setting and turning that speed down a little bit further below the default speed, just so you can confidently hold that tool still and let it do a nice, solid, slow and steady movement instead of you going through a fine detail by hand.
So Ted will link to a call out to various materials and sort of some standard reference speeds and settings for those. One thing, like, why wouldn't you run everything with a fast speed for your auto speed? That's the linear feed rate that Origin moves if you're holding the auto button. Well, at some point it will overshoot, like it'll be going fast into a corner and it will overshoot and you'll get little notches. There's sort of I don't have an image of it, unfortunately, but there's little telltale overshoots that every corner as it rounds, it will go beyond, then it will recover and be back on its line, and then beyond, recover back on the line. So with the default of 10 is a balance between efficiency and productivity, and also cut quality. So if you're cutting harder materials or things that you want to be hyper meticulous, you might go down to 8, 9. But if you're cutting foam or something that you're just wanting to get through quickly, you can turn that up significantly. But practice with most things Origin. We can give you guiding information as a starting point, but you're going to want to practice with the stock you have there. Like, it could be different. You may be using a different cutter. There's any number of different situations that could change how it behaves in your particular case. But always when you're kicking off things like this, practice hopefully in the same material you intend to cut, but then that makes it a direct relationship to when you finally cut on your finished piece. But we also do lots of tests and things like MDF, or if we just want to get a feel for whether or not something's going to work or not. That brings us to the end of the sort of canned examples. We've got a bunch of slides that include your specific questions, that we'll do a little demonstration of those. And continue to ask in the chat, and we'll try and address them as well. So if you can go back to the slides. So this is a great one. We were asked, someone was seeing a little divot where they started cutting, and the bottom of their pockets were not dead flat. So the key with that is to apply constant pressure with the on Origin's handles throughout the cutting operation. So if you kind of are holding it loose and then tap the green button and then hold it with a different downward pressure throughout the cut, you're going to see different cut depths. Like, it's possible to push a little firmer and it'll cut a little deeper. So it's your job basically to try and be as consistent as you can throughout the operation, and you should get clean outcomes. Anything beyond that, just obviously double check your spindle clamp and collet are attached firmly. Collets occasionally need to be cleaned out. I've seen if a collet's starting to get worn, it'll loosen up whilst cutting. And with a up cutter, like the stock one we ship with, that'll cause your cut to gradually get deeper as it loosens and starts inching its way out of the collet. So if you start to feel strange vibration or start to see your cut depth change throughout a cut, just double check that collet. It is a consumable. It'll last a much longer than a cutter, but you do need to keep it clean, and you do need to not over torque it. It's tempting to just go crazy, but from that point on, it gets a little bit of deflection or deformation in it, and it will become harder and harder to fit it. Which, since we're talking about a collet, we should do a prize.
Perfect.
What's a good question about your? Where should you do your offsets for your fitment? In the positive or the pocket?
Perfect.
So answer that on the chat, and our random people in the background will select someone and reach out to them, and you will get an 1/8 inch collet. So the 1/8 inch collet is available in the store.
We don't have one here, but it's perfect for especially talking about inlays for doing these smaller cutters. Ah, look at that. There it is. 1/8 inch collet. And it allows you to use much finer cutters. They're also significantly cheaper for the most part.
Yeah, cutters are it's not so much the material that you start with that's expensive, it's grinding the cutter that's expensive. So if you can, if you're creating like a 1/16 inch cutter and you start with 1/4 inch stock, it's much more expensive than 1/8 inch. So yeah, you'll find yourself getting a lot more value for money out of your cutters if you're doing really fine detail stuff with the 1/8 inch one. Okay, that answers that one. We'll move on to the next one.
This is a good one. Can I scan something and trace it using the pen tool? Well, we're going to use the pen tool for that, which we haven't really dove into. We'll use a good example, like the wrench that comes with the tool, and place that there. Just take a pencil and trace around a bit. Now I'm marking directly on my material and then I'm going to either add to scan or rescan. In this case, I'm just going to add to scan. And we can just follow along.
So worth noting, the pen tool is set up to make kind of faceted straight lines. So in order to, it's great for an octagon or, sort of rhombus type shapes. This is going to be a little different in that it's a curved surface. So what you have to do, or Jake will walk you through that, but just know it's not like a standard conventional Bezier path. It's not a curve. It's lots of straight lines.
I'm just going to redo my scan here. Yeah, you're not going to get curves out of it, but it's nice for a quick and easy shape. Go. And there's our pencil line right there. Into create and pen. Now you're going to use that green button. You're going to drop your points. For this area, I'm going to go a little tighter with my points. Whoops. That happens if you double click on a point too quickly. So I need to make sure that I move away from the point.
Oh yeah, with the pen tool, clicking twice in one place is, you'll see how in the bottom right it's saying finish. That's when you're finishing the shape. It'll highlight blue and it will say, do you want to finish? So this is a great way of just sort of quickly getting approximate forms into Origin, ready to cut. The alternative, like if you are familiar with vector editing software, you can do similar stuff by dropping something on a flatbed scanner and scanning it in. You actually get dead flat shapes. You get the scale already, and then you just trace it. If it's a sort of organic shape that it doesn't sit flat on the flatbed scanner, it can be a little blurry at the edges. But that's one other avenue of doing this type of work. Alternatively, you can talk to Shaper Assist and snap a photo, send it to them, and they'll get you the shapes you need.
What else we got?
So that's that's now a shape that's readily available for cutting in that workspace. So Jake can cut that if he wants. We won't do that right now, but you get the idea. We've got quite a few to get through, so we'll and you can see we can change the cut types to whatever we want. Oh, this is nice and relevant. So one of the questions was, I've got a bunch of hardware that I install in various jobs. I don't want to blow time learning any software. I've got Origin. Can Shaper Tools get me my library? And yes, assist at shapertools.com. Follow the little intro there, and I think we called it out in last week's one as well. You can send in whatever possible, be it a PDF of like the cut recommended sort of cut shapes, the guide you get with it. You might even, you could post us the hardware or send us a link to CAD, or there's any number of approaches for how you get this data to us. The standard approach is just either a sketch or a link to a PDF or whatever, and we'll prepare those files for you with all the depths called out, so that you can readily cut them with Origin without having to touch any software. Yeah, that's that one. So that's assist, by the way. Can you cut a hole that's exactly the same diameter as the cutter? Now, this used to be a problem. Origin couldn't do this initially, but this is one of the areas where our software improves over time. And we've actually added some smarts where it recognizes there's a circle, and it recognizes the cutter is exactly the same as the diameter hole we're trying to create, but still enables you to cut it. Now, the geometry of a end mill cutter is not super great for clearing material out, so it can sometimes be a good idea to go down to a smaller cutter and then use the helix operation, because we don't have like a pecking operation or anything like that. But in most wood situations, I think, what do you got, the engraving bit in there?
I do.
Don't do that with an engraving cutter. Yeah, it'll enable you. It provides a little single dot that you can hover over and cut. It will technically say it's able to helix it as well, but without any wiggle room, it's effectively just going to plunge straight down. Next question. Oh yeah, this one's interesting. So do I need to consider the thickness of my tape when cutting? With the tape laid out consistently across the whole surface, and so long as it's closer than, let's say 3 to 4 inches apart, Origin's not going to sort of change depth. So your touch off, so long as you're not touching off onto the tape, is touching off to the top surface. So you should get a pretty stable outcome. There's situations where you may want to be more refined or take this more seriously, but you're into sort of PCB type territory, and the pressure you put on it is probably going to have as much impact as the difference in tape height. But so long as you keep your tape close enough together that it's not like on a big area of tape and then it comes closer towards you, there's no tape supporting it, you should get pretty consistent depth outcomes. Yeah, so long as you keep an eye on where that cutter is when it does its Z-touch. Yeah, move to the next one. Oh yeah, so software for sort of non-software people. So this is, I'd recommend working in the 2D realm, so vector editing software, 2D vector editing software. We called out what a vector was last week. If you're not software savvy, I'd leave the 3D sort of solid modeling and sort of engineering type software for later. It's sort of heavier to get into. But Vector, that little link I called out there, vectr.com, it actually runs in a web browser, so you don't even need to install the software. You can just create shapes there and then download the SVG. Ted will hopefully be able to link to the tutorial running through the basics of how to do that. Only caveat there is, like, don't expect to be doing sophisticated composing of shapes where you might want to, have something snapped really accurately to something else, or something be, a third of the dimension of something else. You can't do elaborate constraints and things. But for just sort of laying out, sort of rough shapes, things like that, it's really a great way to get started. Then you get into Inkscape is free. It's a package you install. It's entirely workable. It's a little bit sort of not presented. Well, I don't enjoy it as much as some of the others. Affinity Design, in my mind, is sort of a sweet spot for I think it's $50 one-time fee, and then you own that version forever. It's not a subscription, but it's pretty capable. It's the pro end, or the expensive end, is Adobe Illustrator, which is what we show in a lot of our slides and things. But yeah, Affinity Design is a great way to get up and running with most of those capabilities and not feel restricted really in any way. Yeah, move on to the next one.
All right. How do I align cuts to existing objects? We're going to get a little deeper into the grid. A couple different options. Yes, okay. So if I want to do a double-sided cut in this instance, I can. I'm going to start with our standard grid, which is bottom, bottom, left side. I'm going to cut my parts. I'm going to place my file at that 0, 0 mark, which is going to be right here. I can rotate my piece, and I can make the same exact grid, but using bottom, bottom, right side now. So I'm aligning to that same 0 point as I was over here. I'll just go ahead and show you that now. So I have an engraving cutter in there right now, but I'm going to use the side of the engraving bit, so it's actually a 1/4 inch shank. I'm going to lower my depth. Ooh.
So Jake's hovering off the edge. You can't quite see here. He's dropping the cutter down, so it's touching. Yeah, you can see it's dropped down over the edge, and it's just touching the edge, and it's doing a really delicate probe of the edge. Because Origin knows nothing about the actual stock in its standard state. Once it's scanned that tape field, all it knows is where the markers are and where its cutter is relative to the markers. So now we're taking advantage of that and letting the cutter tell us where the edge of the stock is relative to the markers, and then we can start laying things out very accurately.
So now as I zoom out, you can see that exact point down there at 0. I can adjust the size of my grid just as easily. Right now it's at 1/8 of an inch spacing. Let's make it a little bolder, 1 inch spacing. And I get an X and Y readout here at the top of where exactly my origin is in my grid.
So once you've created the grid, you're no longer sort of free-form placing. It's now snapping to those grid increments. And then, so if Jake was to load in a shape, he'd then be able to place it. And you'll notice if he rotates, the shape remains orthogonal, or sort of, you don't have to worry about being 2 degrees off in your placement there. Maybe walk them through the anchor points as well. So if he wanted to place that, well, I'll let you describe it.
So right down here where it says anchor, currently I'm grabbing the very center of the shape or of my design. I want to use my bottom left because I'm going to snap that bottom left to my 0, 0 point. And that's what I'm going to be using to reference my next side once I flip.
Now that's the, you'll notice that green line around the outside edge. That's, or I think you've drawn a bounding box around it.
Yeah.
but those anchor points are the bounding box of that shape. So if you were to say place a circle, it wouldn't be using, it would be using a square bounding box of the entire circle. So sometimes if you want to do very specific placing, people actually bake in a bounding box, kind of like what Jake's done here. They'll put a guide, a big rectangle around their shape, and then place it relative to that exactly where they intend it to land. So if I wanted my shape to be 3.2 inches in from one edge and 1.63 from another, I would put a bounding box that actually the bottom corner is 0, and my shape relative to that is 3.2 and whatever the other number was I said. That's one other way of being very specific. This one here, you'll be placing in increments of the grid in both X and Y. So that, in most cases, gets you exactly what you need, but there are other options.
Can I use grid to align shapes to pencil marks? Yes. I have already marked out this panel with a crosshair. Say I have a larger surface and I can't necessarily grid off of an edge. I have my engraving cutter in there. I'm going to use it kind of like a stylus. Right here are my, X marks the spot. I want that to be the center of my shape, right around there. And I've given myself a long horizontal line. I'm essentially going to touch off on these marks and then mark my center. And it's going to show a little bit more about the UI of the grid process as well. So for this, I'm going to get this out of the way so I can get a closer eye on my engraving bit. I'm going to lower it just so that it's hovering above my material. And again, using that engraving bit as a stylus. Important things to remember. We want to set our bit size to really 0.
It actually doesn't need that. You can leave it and use the centering option.
Oh, okay.
Yeah. So put that back to 1/4. And then in the center there's the option that says edge. So this now updates live, and it will toggle between top, bottom, or centered. So when you're on a line, now he's looking at the very point. He's using the center of the point instead of touching the top or the bottom edge of the grid. So he's looking underneath there to get that perfectly aligned on his mark. The screen's pretty good, but if you're going to this effort, chances are you want it more accurate than just quickly clicking on screen.
And I've surpassed my center point, put my 2 outside points, and I'm coming back to my center crosshair, and I'm dropping it right on there. Now I have a new 0, 0 exactly on my physical X drawn on my material. Again, really handy if you're doing something in a larger space, and you don't have an edge to necessarily reference off of. You can still get a perfectly parallel shape.
Yes, I think the question was tied to, like, if you were doing a large table and you had tape on it. This means if you were doing a little logo in the left edge of it, you don't need to tape the whole thing, or if it's in the center, you don't need to probe the edge and then go to that point. If you've got a pencil mark, that's any amount. You just put tape near that, scan that, and then you can do your little operation right there. Back to the questions. And then, doing cuts from both sides. This used to be a challenge, but with the revised grid, it's actually super easy. So you saw Jake probe the bottom left. I might as well do that again, I guess.
Yep. Just to kind of show a variety. Let me get rid of this.
So worth mentioning, grid is super powerful for any very specific placement of objects. Like, this is how we tell Origin where the physical world is. So then we're super accurate within that. And you'll notice it's drawing the x-axis for us as we go. So Jake's probing the left-hand side. So this would be the bottom of the surface. And then if he was to cut his holes here and then flip it, he could then probe the right-hand side. So
let's just go ahead. Oh, there's no tape on that side.
So yeah, he's got a few things colliding with him there.
Smaller workspace.
Yeah. Which means, you can work on both sides. You don't have to probe the left side. You'll notice that with those little toggle buttons in the middle. If you
Back to grid.
yeah. So we'll just
New
show you what
grid.
it looks like. So he's lowering down to get to the right height, then probing on the left, right. So this is where he can choose the bottom, top.
Sorry, forgot to do these.
Yep. So he's doing the left, and he's spreading these two. The first two probes are the most critical to make sure everything's dead straight, because the left, the third probe is always at 90 degrees to those first two. So if you do those first two really close, and there's a bit of dust or some, a wood chip, that introduces potentially quite a lot of error. But if you're a long way apart for the first two, you get very accurate outcomes. So now this would be, if it flipped his board, he's now probing from the right. You can then place your shapes. Do you want to show them that quick hack for flipping a shape when you place it? So say, place your leg. I'll work you through it. Place the leg. So there is actually the ability to flip a shape on Origin. Like if you forget to do it in your digital file, we'll go back to the screen. So here's Jake about to place his shape from as he would on the top, but now he's on the bottom, so he wants to flip it. So go to scale, and then you can actually tell it to decouple the proportional scale, and then select width and just hit negative, and then go done. So they actually flipped in the X, or horizontally. So now if he went and placed that using the anchor point on the bottom right, he could match the top and the bottom, should there be details from the top and bottom. Obviously, it's cleaner to create a top and a bottom asset, in your software of choice. But if you're stuck in the field, that's a great way of working around that. Right, that's enough grids for a little bit. Let's see what else we got. Oh yeah, nesting shapes. So you can lay out your shapes. There's plenty of I think Fusion's actually just introduced one where you can very accurately lay out shapes on your object. With Origin, you don't cut one pass across a whole large panel, I guess is important to remember. So even if you did have all of your SVG shapes laid out on a panel of ply, if you were to cut one pass deep, as often on a gantry CNC you would do, it would go around and cut to one depth across the whole surface. It would destroy all your tape field. So then as you move across, all your tape would be cut. So it would be difficult to track throughout that process. So with Origin, it's more common to sort of nest as you go. So as you're placing shapes with Origin, because you can see what is being cut, maybe have you got a workspace there with anything like that?
Bring something in.
So you'll see A, the shape you're cutting, B, the blue line, your cut history, showing what's actually being cut away. That enables you to accurately place the next object, or you could just do a quick air cut to show what that looks like. Then what the key there is to start close to you and then work forward. So yeah, Jake's just showing you what that kind of looks like. So you can see here there's the cut history, which is the area that's actually getting cut. So that means if you have a shape that interferes with that cut history, you know that it's going to get cut by adjacent shapes. So that enables you to really accurately use the little nooks and crannies and scraps on a panel, and you can sort of organically do it as you go. Because, yeah, you can zoom in, check it all out, and get exactly what you want there. The other thing you can do, like say you've got a panel with an area that's got a bunch of partially cut elements, you can actually rescan that. So you could go add to scan, and what it's going to do is bring in all the existing cut elements. So you'll be able to find little areas you can make use of with Origin and just cut, because you can see what's actually being cut when you scan it. It will illuminate exactly.
In addition to adding more tape if you need to.
Yeah.
If you cut through too many markers, you can always add more tape, add to scan, and carry on.
Right. One more. Oh yeah. So this one I think is was asking how to A, make the logo, and B, how to scale it. So if you've already got the logo as an SVG file, it'll be much like how we flipped that shape. Whenever you place a shape, just grab the home.
Let's grab the home.
Yeah. Jake will walk you through this.
For this sake, I'm going to grab that center anchor point. And right here in our options on the side, we have scale. Now, an important thing to note, I'm going to cut this with an 1/8 inch cutter, but I can make this bigger and cut it with a 1/4 inch cutter. But if I make it smaller, as we talked about earlier, our radiuses are going to shrink with this. So if I make this, just actually use our calculator and double that.
That one's actually really powerful, by the way. Like multiplying it by 2, or you could make it, 125% its size by going times 1.25. Yeah.
And there you go. Just kind of show you what our corner radius looks like now. Inside. If I were to change this to a 1/4 inch cutter, I can fit in there with a 1/4 inch cutter.
So yeah, when you're placing shapes, you have the option of making them any scale you like. Just make sure your cutter can accommodate that change in detail. And then, yeah, to create that shape, Ted might be able to link you out to, there's some examples of tracing vectors, tracing raster images and turning them into a vector using Inkscape. There's also, what's the name of the one? There's a little program on like an iPhone. Do you remember the name of that?
Capture.
Capture. So yeah, if you do some Sharpie marks, that is your logo, or your logo is pretty legible, you can create SVGs, and it has some basic tools for adjusting how that comes out. Failing that, there's always Assist. We get a lot of like raster images of logos come through Assist. People just want to, turn that into either an engraving, anything like this, a resin pour, or a full-on, even full-on like this, an inlay. So yeah, it's up to you how you want to approach that. And next question.
Now on to some of the live questions.
So yeah, we'll just go through the ones that have cropped up during this actual the presentation now. We've still got about 7 minutes left, so yeah, if you got any remaining ones you want to ask, get them in there now, and we'll try and get to them. So why leave a auto mode on for all of a cut? That is up to you, really. Origin's great at operating like a handheld router. Like, if you're familiar with a handheld router and you're using Origin, you'll find it really intuitive. Like the sounds, everything carries over. So you'll know what speed to move Origin based on the sound, and it'll just give you some more advanced, precision behavior without lugging around patterns and all that sort of templates and whatnot. So that means, there is an advantage to not having auto mode on all the time. That gives you the ability to go fast for straights or, long, slow curves, and then slow down in corners and handle them with auto mode. But yeah, there is also an advantage for auto mode. Sometimes if you've got a material that has to be, the cutter needs to be loaded a specific way the whole way through, like brass and things like this, you're more likely to want to have auto mode on the whole time so that each chip is the same size. You don't want to have that being too variable, because the cut qualities change quite a lot depending on the feed rate. So yeah, it's there as an option. You don't have to follow one way or the other. It's totally up to you.
For things like engraving, hole boring, using your helix cut, that's all great opportunities for, well, helix cut isn't automatically an auto cut, so it has its pluses and minuses. But.
So sorry, we're just reading a longer one here.
Is it?
Recess taillights did a large offset. Recess. Yeah, you can get into situations. So Origin's toolpath is trying to produce a conventional cut. It's avoiding climb cutting wherever it can. Now there are situations where you do, like in this case, someone did a large negative offset, which kind of corrupts that in a way. The negative offset means what Origin thought was a conventional cut becomes a climb cut. So you would you'd have to do some math and make it the opposite type of cut, and negate that.
Pretty much,
so
yeah.
you would take an inside cut, make it an outside cut, and then offset in the opposite direction, and then it will go the right way. So it's a little bit of a workaround, but it is possible to force it to go in the direction you want, as long as you keep track of that. Yeah, if you want to, the next question is, I've got a bunch of tick marks in Fusion. I've drawn them, and I want to engrave them with Origin. Now, they're open paths, so the Fusion exporter is working with, ordinarily in its standard mode, working with solid geometry. So it takes closed, complete shapes, holes, and it tries to convert them into the appropriate color-coded SVG that's all the right scale. So that's great for when you're literally cutting geometry. But the moment you want to do these little tick marks, like degree marks on a circle or something, you're going to want to export the sketch. So there's another option. If you tick advanced, you can then go in and tell it just to export an entire sketch. So whatever elements you have in there will be available for cutting. But just keep in mind, you won't get all the sort of solid body processing automation you get with the standard mode of operation now.
Next question coming in is, do you have any recommendations for pocketing areas larger than the base of Origin? So the tricky part about that is we can't be too wild with our pocketing if it's larger than the base, because obviously Origin will tip into the pocket that we're creating. Well, there are a couple of things, a couple ways to get around that. Say I have a larger pocket. For one, Origin is very front weighted, so you're going to want to start at the bottom and work your way up. But before even doing that, you might want to consider doing your inside cut first. So as we talked about earlier, pocketing is a two-step process. You are usually clearing out material and then doing your final inside cut to get that final line. In this case, we would reverse that, do our final inside line first, so we still have material that we're riding on. And like I said, kind of fill the bucket side to side instead of starting in the middle and maybe carving all the way out. We want to go side to side and work our way up to the top, relying on the weight of Origin at the top.
Then, okay, so engraving onboard text. Occasionally got a message to the effect of the cut path was too complex. What does that mean? So, yeah, that doesn't ring a bell, I'm afraid. The only thing I can think of with basic text, oh no, it's not basic text, it's simple onboard text. Yeah, the only thing I can think of there is the path is an open path. So an open path has to be cut starting at one of the open ends. This is so that you don't start cutting in the middle of your letter and complete it, but have left out a big chunk at the beginning. So when you're cutting an open path, you have to choose to start at one of the highlighted endpoints. That's the only thing I can imagine there, unless there was an unbelievable amount of geometry in there, but I don't think you'd get there with basic on-tool text. We can feel free to send a message to support@shapertools.com. I'm happy to dig into that more, understand what's going on there. Can we demonstrate helix mode? And actually, there was another question tied to helix mode. There was someone who was having to say inside cut for each one of his circles he'd created, and would like to be able to have it automatically know that it's an inside cut. So that's handled in a 2D vector editing app, and you just have to color code it appropriately. So a white fill with a black stroke is an inside cut. If the SVG was something else when it was brought in, it will interpret as something else, be it a pocket, outside cut, guide. But yeah, if you just take all your circles and make them all white fills with a black stroke, they will interpret correctly on tool.
So let's go ahead and create a 0.45, well, let's just make it even. Half-inch circle, place it there, and you'll notice as soon as we hop over into cut, we get the option to turn on or off helix down here, because the cut path, the corrective range, is inside of the corrective range. So I'll go ahead and make sure that is engaged. I have my depth to 0.7. Put my glasses on. Now I'm tapping the tool once and just holding very still. And it's going to work its way down, slowly changing the depth of the cut. There we go. Now, if my auto speed was on the slower side, if I'm doing a ton of holes, say I'm doing an entire table like this, I can edit that auto speed. And as long as I'm holding the tool securely and making sure that that it's not moving on me while I'm doing those helical cuts. But it's nice, you don't have to edit every depth as you go down. If you're just doing a hole, it'll work its way down on its own.
Worth mentioning, the auto setting and the plunge setting come into play with helix cutting. So if you want it to plunge very rapidly and have a less or a more aggressive helix, you can turn the plunge speed up. So it's tied to the plunge rate you're going to see in regular operation, but those two come into play. So it's worth tuning exactly the auto and plunge speed you're going to want to use when using helix. If you find it going down too slowly, it takes too long to perform a hole in just basic MDF, consider changing those settings, speeding them up.
Last question. I know you've done this plenty of times before.
Yeah, so HDPE is notoriously difficult to adhere anything to, which is part of its great features, but obviously, yeah, shaper tape is not that fun to keep stuck to that. So we don't have any here, but painter's tape is great to lay down first. It actually adheres okay to HDPE, and then you lay it's fine. And then you lay shaper tape on top of that. Also, I find if you go beyond the edges and just bring the shaper tape down, you can run another layer of painter's tape along the edge just to stop it, because it usually starts peeling at the seam or where it's been ripped, and then it just sort of peels up and does whatever it wants. So if you can get painter's tape under it and then a little rim of tape around the edge, you're good to go. It's also another example of when potentially cutting using a tape panel, a board with tape on it that's the same height, can work pretty well as well. There's lots of options for that, but yeah, HDPE is great to cut. That's an example of where you'd want to use one of the great cutters. It cuts pretty well with anything. O-flute cutters, a particular geometry of cutter that's great for plastics, hard plastics and soft plastics. There was actually another couple of questions. One was someone was asking about a conical cutter. I think we tried to mention it in the previous one, but yeah, Origin doesn't know anything about the geometry of your cutter. So it doesn't know that it's a V-bit. It doesn't know that, do you have any of those examples around? I'll let Jake describe what's going on here.
Yeah, basically when we're telling Origin what size our bit is, say a 1/4 inch cutter or whatever, we're using just the tip of the cutter that's being introduced into the material. In this case, conical shape, it tapers in. We're still going to take that measurement with the very tip of the bit. Same situation here, which is a round over bit. We're going to use our digital calipers to measure that, set that as our bit diameter, and play with offsets to find that perfect contact point and get that, for, in this case, perfect curve. In this case, the deeper or the closer, smaller the offset we have, the more dramatic the tapered angle is. Did I explain that well?
Yeah, basically with this little guy, yeah, if that's an 1/8 of an inch across at the top, and you measure an 1/8 of an inch, the toolpath is going to be centered, half of that off the edge of your surface. So it's going to run along this edge, and as you plunge down, if you're down, I don't know what, is that that's a 1/4 inch radius. If you plunge down to, 1/4 of an inch, you're going to get a perfect round over with your geometry. Worth mentioning, this is a huge advantage for if you're doing lettering and sign type applications over like a bearing following bit. So if you're trying to do a post operation with a traditional router, the bearing will dictate the level of detail you can get to. Whereas these, you can get even more crazy detail with a tiny point like that. So that can get right into like the corner of we don't have any good examples here, of like an N or something like that, and round it over consistently the whole way around, rather than a following bit that's going to miss those inside corners. Any others? Sort of pretty close to time here. Did you want to do... There was one thing we mentioned there, workspaces. So this is a powerful tool to stay on top of a project. We started touching on it, but we thought we were going to run out of time. We'll actually dig into that now and show you some of the ways that you can stay on top of A, projects on your workstation, B, just all projects. Just keep them organized and know exactly what state they're in.
Yeah. So as I move from one workspace to another, I want to show you exactly what comes up on the screen. It's going to recognize that tape. Now this is the workstation. We've scanned this thing hundreds of times, but my most recent one that we did was the home inlay positives. And it's going to remember to name a workspace, you stay in scan mode right down here at workspaces. A couple things we can do. As the selected one in blue are home inlay positives. We can either rename that, we can duplicate that if we're making different versions. We can also get rid of it. I typically don't recommend deleting workspaces until you're absolutely sure. It's not a necessary, it's just in case you ever want to delete, but I typically do not delete my workspaces. And same thing when I hop back over to this workstation, it's gonna give me, whoops. It's gonna recognize that as what we worked on earlier.
And that's mapping to the green button as well on the handles. You don't actually need to take your hands off Origin to just jump between projects. We've found people in schools and environments where they might be sharing a machine between different people on one workbench, that to be super effective to jump between projects.
Especially a two-part project. You have the negative of your inlay and the positives on your inlay. Those should be two different workspaces. They will be two different workspaces. Do yourself the favor of renaming them. So if you ever need to come back, recut that part, all the work is already done. You have everything there. Any other ones?
Yeah, I noticed there was one asking for the maximum size helix hole. So we actually linked out in the, Ted included it in the chat, to a community post about helix operations. So the maximum diameter cutter that you can put in Origin and not have it collide mechanically is a 1-inch diameter cutter. So that's, I mean, you're probably not going to want to use something like that for helixing, but there's a balancing act with helixing, and it'd be worth checking out this diagram in the link. I should have put it in the slides, but in the community post, it talks about there's the maximum corrective range. So that's the area that Origin can move across. And you'll notice as it gets near the edge of that corrective range, Origin starts to decelerate. So it doesn't like collide with the edge of your correction range. That's a pretty ugly experience. So it slows down at the edge, which means there's a sort of border around the edge that's not super useful for helixing because Origin is going to be slowing down way out there. So the actual usable corrective range is about 0.41 inches. So then if you put a 1-inch cutter in, it's like 1.41 inches is the total diameter of cut you could cut sort of efficiently with Origin. And then, yeah, if you're using a 1/4-inch cutter, it will actually leave a little puck in the center when it helixes down. So it'll be 1/4 inch plus 0.41 inches of corrective travel. So that gets you a 0.66 inch hole. So yeah, it's a great way of like really being productive. A lot of people for these size holes will find it the stock cutter is not appropriate for that. You're going to want a slightly larger cutter, so maybe a 1/2-inch cutter. Do we have that guy?
Nope.
Thought I did. Either way, you're going to want to find a cutter. I can show you what you don't want. So this is an example of a carbide insert cutter that doesn't have the ability to plunge. So there's no cutting elements in the center there. So if it goes straight down, it's going to collide with the center. Now, worth noting, helix is one situation where it can work around that in that the cutter is going to be moving about 0.4 inches as it spirals down. So it could clear that. But just if you were to do a regular cut using a cutter like this, it would try to plunge straight down, collide with that uncut material, and Origin would sort of buck and potentially make an error or a incorrect cut as it tries to plunge. Yeah. Another couple of stragglers before we wrap up here. Are there any materials you cannot cut with Origin? So yes, it's not set up for cutting like hard ferrous metals or granite, concrete, porcelain, things that require like abrasive aggregate type cuts. There are like cutters that look a little bit like that you can experiment with. So this is a burr cutter that you would use for composites like fiberglass and things like that. There's some like diamond surface cutters that will cut other hard things. But yeah, Origin is, it's a trim router, it's a hand tool. It's not really set up for any situation where you might need liquid cooling or anything like that. Like always keep Origin dry. And yeah, I mean, we can sort of lay out some sort of standard materials here. Obviously all the woods, foams, most plastics. Yeah, these are all good to go. Corian. It's just a matter of finding an appropriate geometry of cutter, and Origin will be able to manage maintaining precision in that material. So this is a soft copper, acrylics, foam PVC, MDF, foam. This is cross-linked polyethylene. I think that's a 4 pound per square foot one. Melamine coated chipboard, veneers, corian. Yeah, most of the cutters that you would consider approaching with a handheld trim router, Origin's very much capable of cutting them. But yeah, use your judgment when you're encountering really hard materials. Yeah, it most likely will just damage the cutter. But yeah, don't make sure you don't bring liquid into the equation, and yeah, pay attention to the appropriateness of that material. Is there a limit on saved workspaces? So we have a large hard drive, and workspaces take up a moderate amount of space. There theoretically is a limit. We have never encountered it, and you have the ability of, maybe you can show quickly, if you did want to get rid of a workspace, how to do that. So you just go into Scans, Workspaces, And then the little 3 dots come up with the option of renaming, duplicating, or deleting. So you can just delete that there. So yeah, and for the most part, we'll just go back to that. We just leave it in at the top there. There's all workspaces, and you can choose visible workspaces. So to avoid the clutter of workspaces, can you change it to visible? To avoid the clutter of seeing workspaces that are redundant or not currently in view of Origin, if you just hold your hand in front of Origin, you'll be able to see. So you'll notice the moment the camera can't see that particular unique tape field, it thinks there's no workspaces available. The moment it sees them, they're available for cutting. So in this state, you keep your handling of workspaces as simple and predictable as possible. Yeah. So I mean, that's us for time. We'll wrap it up there. But yeah, thank you for coming along, and thank you, Jake, for helping out. That was awesome.
Thank you very much, Sam, and thank you, everyone. Welcome to the world of Shape Origin.
And be sure to post any projects you make. There's a little hashtag in that last slide, Eric. That's our little Shaper Made Instagram tag. So if you make anything interesting, be sure to share it up there, and we'll repost what you're doing. So say hello to the community, jump into the docs if things are confusing, and yeah, reach out to us. Everyone's helpful and enthusiastic. Great to have you on board.